Not yet. Well, I guess we do kind of, but then we want to do something first. Why do we factor out the x and 5 there? Because one person see it? Hint, hint, I even highlighted for you. Emily?
Because there's the x squared plus -1.
Is a common factor, right? Tell me what's right, Emily.
Where y, x plus 5, x squared.
That's right. I wrote x squared minus 1 first. Is that okay? Is that okay, guys? Because that's my common factor. If you don't believe me, let's multiply it back. X squared minus 1. By the way, after all, I mean, what is x squared plus -1? Isn't that same as x squared minus 1? By definition of subtraction. Thank you, Chansu. So x squared minus 1 times x, don't you get the right previous term? Plus x squared minus 1 times 5, don't you get 5 times x squared plus -1? Yes? We're done, right? No? We're done, right?
No.
Oh, we're not done? Oh, somebody says different. You see, I don't see any difference of squares. Where? Oh, raise your hand if you see it. Where? Where do you see differences? Lindsay? X squared minus 1? Well, I don't see any squares around 1. She's right, though. Elizabeth? Yeah, 1 to the second power is still 1, isn't it? 1 times 1. You're right. So, do you think it's kind of, do you see better now if I write it this way? Something squared minus something else squared? It's 1 squared, right? So, what does then this become? John? X squared minus 1 squared? It's a difference of squares, so how does that factor? X squared minus 1 squared. John, remember, if I have, I don't have this. A squared minus b squared. Isn't that difference of square? What does that factor to? A plus b times. Very good. Now instead of a, I have x. Instead of b, I have 1. So how does that factor? You got it. There you go. So, how many people got this as your answer? Raise your hand. You're very good. Easy or hard? Pretty straightforward, isn't that right? This is what kind of stuff you would have for your homework. You got a question? Sure.
I got x minus 1 times x plus 1 times xy plus 5.
That's wrong. Okay, how'd you get that? Look at what we did here. You factor out the y first, then you factor out the group 2's.
Okay, so in the beginning I just...
So guess what that means if you didn't get this? Huh? What? You got it wrong. Now you have to figure out which part you got wrong. Does that make sense? Because there's no other way to factor. Okay, once you factor, this is the only answer. You don't get something else, okay? If you got something else, guess what? It means you got it wrong. You now then have to figure out what you did wrong. Okay? Question? Yes, Matthew.
Why did the 5 times x squared plus -1 change to x plus 5?
Oh, instead of writing, are you talking about right here? X squared plus -1 right here? Yeah, what's x squared plus -1? I just I simplified it.
Why is there a 5 there? And next.
Because why is this 5 right here? Look at the previous step. What is your GCF of 5x squared plus -5? We factor out a GCF from these two binomial, which was? Right here. Oh, right here. Do you see 5 and 5, -5? Are you talking about this 5? I got the 5 from factoring out 5 from these. This? Well, that 5 is right here. This 5. Okay, that's a good question. Matthew, do you know how to do this? If I have x times y plus 5 times y, right? Can I factor out a y from both of these? And what do I get? Hold on, guys. We get what? No? Guys, hello? If I have x times y plus 5 times y, I have a common factor of y, right, Matthew? So what does that become when you factor out a y? Excellent. It becomes y times x plus 5, right? Well, instead of y, guess what I have? X squared minus 1. Yeah, so that's where that 5 comes from. You see we have 5 right here? That same y is still there. Instead of y, we have x squared minus 1. right? It's just a substitution, right? All right, so we got x squared minus x minus 2x squared minus 2x. So this is a kind of silly question, but by the way, let's do this together. Do you think I should group them by 2s or 3s? Emily? Oh yeah, I do have a greatest common factor, which is x. You could do that way first. But there's actually even, I haven't even talked about this, but look at what it says up here on my board. Always?
Simplify.
Is this something we can simplify before we go? Talene, is this something we can simplify? We have what?
We have x squared and x. Like we have to do it negative x squared minus 3x.
Yeah, we have like terms. Guys, shouldn't you simplify first before you try? Okay, so don't even forget that one, right? You should always like simplify. So you could try to do it this way. It's not going to come out because you're not going to get any common factors. So you should always simplify. Question?
No.
Oh, then, so you become x squared what, guys? X squared minus 2x squared and then negative x minus 2x, right? What do we get when you simplify? Yes, Anais?
Negative x squared minus 3x.
Yeah, are we done? Are we done here? No. You got to factor out your now GCF, which is x or negative x?
Negative x.
Negative x. We don't want the first term to be negative, right? So we factor out a negative 1, we're done. So don't forget to simplify, just because you have 4 terms, right? If there's like term, you should simplify them home first. You know what I mean? So that's why it's kind of a silly kind of question, but you know what I'm talking about, guys? Don't don't get surprised when you get something like this. You should always simplify, even before you're looking for GCF, even, right? You should always simplify, right? Let's just make your life a lot simpler. So you see the rule of factoring. Little gift from me here. This one, by the way, there should be another box. I messed up. Can you put another box right here? On the bottom? There should be one more box, right? And then draw under there. I forgot one box. Anyway, that's fine. Okay, so what this is to help you when you come up with a problem to factor. This is a kind of a roadmap. It's kind of a, what do you call it? Flow chart. This is how you think through your head, right? So there's a stop sign. So this is what before you do anything, you should stop in, see if there is a GCF. Thank you. So write down GCF in big GCF. It's just, and even before GCF, what should you look at? I'm going to write it up here. Simplify. Always what?
Always.
That's right. Always simplify.
It's in standard form.
Oh, and then write it in standard form. Okay, good. Yeah, you should write it in standard form too. Okay. Then, no, always simplify. Then write it in standard form. Then, of course, GCF. Okay. Okay, I'll write that one for you. Standard form. Yeah, standard form always helps us, doesn't it? It's not standard form, is it? Standard form. Well, you know what I mean. Because it helps us to kind of recognize things better. Okay, so you stop before you do anything. Okay, after you did simplify and then standard form, you stop and of course you look for your GCF. Okay, GCF. Now, so look at like all the examples that we did today. Look at your GCF. What did you do? What did you? Okay, what did you do next? Okay, actually the better question is, what helped you to take the next step? What did you recognize, or what were you looking for after you do your GCF? So you see how this thing's thinking right here? So after you do your GCF, you don't just go on and factor. What helps you to factor a certain way? Yes? That's exactly right. You look at the polynomial and you see whether it's a binomial, whether it's a trinomial, and so forth. So what are you looking for? Number of what? Terms. Right? Because if you have 2 terms, after you factor out your GCF and you have 2 terms, only way that 2-term binomial, right? 2 term. Only way that binomial will factor is if you have a what, guys? What goes in here? DS is correct. If you don't have difference of square, in other words, if those 2 binomial is adding, right? Is there any chance it's going to be a factor? No. Only way for a binomial to factor is if you have a difference of square. Right, guys? That is after you factor out your GCF, right? Are we okay there? Lindsay, question? Oh, you're stretching? Okay, Lindsay, guess what comes next? After we look at 2 terms, what if you have what? What else can you have? 3. You could have 3 terms. Exactly right. So if you have 3 terms, which one do we like the best? If you have 3-term polynomial, we like the polynomial with, yeah. Yeah, that's a special type. Which one do we? That's what she's saying. No, that perfect square is a special type of one. Yeah, what do we like the best when you have perfect trinomial? Yeah, just the x. Don't we like the one where 1x squared plus bx plus c? Don't we like that one best? Because if it's 1x, right, we know it's x times x and so forth, right? It's easier to factor if it does factor. Does that make sense? Which one do we like the second one? We want the a x squared plus bx plus c, right? And do you guys remember my big hint on this one? You don't remember my big hint? If this is ax squared, remember I told you to get the what? Emily? Yeah, the closer one. Like, if you have 10x squared, do you want to try with 1x and 10x first, or 2x and 5x first? 2x. Yeah, it'll give you, I think, better chance. Okay, because the book likes to give you those. Okay, and then the last one is, you're right, PST, but PST is really a special type of this previous term. Isn't that right? Isn't that really ax squared plus bx plus c? It's a special type. So you could, I'll put PST there too. Question?
On the second one, you just did big hint.
No, I just wrote down big hint, you know. Because whenever you factor this one, remember if it's ax squared, right? Don't you use the one in the middle? Instead of the 10x and 1x, you use 2x and 5x, you know, the one that's closer. Yes? That is what? Yeah, so ax plus bx plus c is not a perfect square. It doesn't have to be a perfect square trinomial. Yeah, of course. Yeah, just because you have c squared doesn't mean it's perfect square trinomial. Perfect square trinomial, you guys remember, it looks certain way, doesn't it? It looks like a squared plus 2ab plus c or something. Anyway, okay, and what's the last one? What goes in here? 4 terms or more. Okay, sometimes you have more. You don't really have too many. Yeah, but it's just 4 terms is good enough. Okay, 4 terms. So if you have 4 terms, if the polynomial is 4 terms, only way you know how to factor is, first you group them by what? By how many? 2s. When you group them by 2s, after you group them by 2s, what do? You look for GCF of each of those 2 binomials, right? Remember? And then you look for another GCF within those, right? Remember that? And what's the last term? You group by? Group by 3 is correct. And when you group by 3s, what are you hoping these 3 terms are? You hope that the 3 terms are the, yeah, that's right, PST, perfect square trinomials. Alright, so that's what you're looking for. Does that make sense? Yes? Okay, isn't this what we've been doing? So this is going to help you when you do your homework tonight, or when you actually take a test, right? Isn't this what you're thinking through when you're factoring?
We'll use this on the test.
Yes, but you don't get to use a sheet of paper. You have to know in your head. You have to memorize. Yeah, but it's not that hard to remember. Yeah, question? I don't know. There was something, but then we printed so many times it's gone. I don't know what it was. Sorry. Yeah. Okay, any question? Are we good?
Yeah.
Does this make sense? All right. Good. This will really, like I said, guys, this is going to really help. Doesn't it? Isn't this nice? Isn't this nice? Doesn't this organize your thoughts really nicely? Okay.